Hello YouTubers, Tros here. Today I'm trying out a new game called Shenzen I. This is a game by Zachtronics. I've played a few of their games before. Most recently, I played Infinifactory last year, and actually my channel sort of started with me playing SpaceChem and uploading some of my solutions to that, because it actually had a export to YouTube function. This game is basically a game about making cheap electronic gadgets. You're given some microprocessors and have to write some code and hook inputs and outputs up to make little devices. So apparently the story is you've left your country and come to Shenzhen, an area in China known for electronic gadgets, and there's apparently several manufacturers and a big market where you can buy different components cheaply and then make them into products and resell them. So apparently we're looking at a live camera here. The weather is hazy. It's 24 degrees Celsius, which I'm not known. I live in the United States where Fahrenheit is the norm, but I believe 24 is pretty warm. Air quality is poor. Drone activity is light, though. There's data sheets here, which opens up a PDF manual. I actually found out about this game about a month ago, and there was a limited edition special version, which comes with a printed version of the manual, so I have that open just to my right. We're going to go to Concept Mail. Welcome, dear new employee. Thank you for joining Shenzhen Longtan Electronics Company Limited. We aim to become a world-leading company in the electronics industry and a respected brand with products in homes, offices, and public spaces across the world. Longtan Electronics was founded on the following principles. Diligence. This means both diligence in your work and diligence in your life. When you encounter a problem, do not give up. Even if you are not talented, by working on it every day, little by little, you can achieve the goal. Connections. The process of creating electronics is the process of creating connections between different components. In the same way, we do business by making connections with people. Therefore, it is important to always be making connections in your work. Salabrousness. An unhealthy mind creates an inefficient design. An unhealthy body builds a defective product. Follow correct eating, correct behavior, and correct thinking in order to maximize your potential. Please keep these principles in mind as you contribute to our efforts. Wang Yohong, CEO. Okay, well, there's some more flavor text here. But we are going to move on. Important, read the manual. I know you're so good at engineering systems and life in general that you haven't needed manuals in ages, right? Well, trust me on this one. You really, really, really want to read the manual here. Even better if you keep it handy as you work. Don't be like the non-manual using person who just quit just before you started and whose name shall never be uttered again. Okay, well, it's the game basically telling you you're going to need the manual. I've read enough of it, the whole beginning part, and there's a section that goes on to describing the different little processors you'll get to use. I've definitely read the first 5 of them or so. I'm sure in this video I'm not going to get into any of the advanced processors. So I believe this is our first job here. Security camera fake. This product is an imitation mock security camera. It has 2 blinking lights. The first light blinks in a regular pattern. The second light is an internet light, so it should be blinking in a more random intermittent pattern to resemble data upload. As you will notice, the design is partially complete already. A previous engineer quit before finishing the assignment. Note the timing diagrams in the verification tab. When you simulate, your outputs should match these expected values as indicated. Let the simulation run for 4 full test runs to make sure you have a proper solution. I'm absolutely certain you can do better than that last person. Okay, well, this is our introduction puzzle here. Objective, create a working design for this product. Open in Concept CAD. Concept CAD, create a working design for products to view histograms and leaderboards. Let's... Oh. Delete. Design 1. Open design. I guess copy, name, delete. Fake surveillance camera. Active and network are simple outputs connected to LEDs. Control the active and network outputs with fixed repeating signals as indicated in the verification tab. This information, let's go to verification. So here's what the camera looks like. These are the little electronics. This is the active light. This is the network light. The active light should be, looks like, off for 6 cycles, seconds, whatever it is. Cycles, I think. And then on for 6, off for 6, on for 6. That should be relatively easy. And then the network. Well, it's off for 4, on for 2, off for 1, on for 1, and then that repeats. So different repeating lengths, but that should not be difficult. Here is the MC4000, the basic or simplest processor described in the manual. It's the cheaper version of the MC6000, which has some more inputs and outputs here. The game has 2 different types of inputs and outputs. These P1s are basically analog. You get a value of 0 from 100. Generally, you're going to only be using 0 and 100, but there's a few times when you want to have varying, basically, voltages. Where these X pins are a data bus, basically, that you could connect between processors and send numbers between. The numbers are between negative 999 and positive 999, where the P pins are 0 to 100. So this is going to, when you start it up, move a value of 0 to P0, so that will turn the light off if it's on, and then sleep for 6 cycles, and then move a value of 100 to P0, that turns the light on, and then sleeps for 6 seconds. These simple processors, I believe, can have up to 9 instructions, where, like I said, the 6000 version can have 14 instructions, and then there's more and more complex things from there. So let's start this off by moving, let's connect things. Well, move 0 to P0. And it's like, hey, P0 is not connected. Let's connect it. Sure. And then we'll sleep for 4, and then we'll not P0 2. Oh, okay. We will move 100 to P0. Not does work, but it works on the accumulator. Accumulator, for those of you who don't know, actually many simple computers in the early days didn't have, well, computers today have registers that are quick access on chip, much faster to access than RAM, but back in the day that wasn't really, not that it wasn't possible, but it was a lot more expensive to do, so they only had one, and all operations put their result in the accumulator, and usually also use the accumulator as one of the operands. So if this case, if you have something in the accumulator and you want to add 5 to it, you would literally just add 5, and that adds 5 to what's in the accumulator and puts the result in the accumulator. And you can do math like that, add, multiply, subtract, divide, and then you can, oh, is this greater than 0, less than 0, do different tests and stuff. So we are now here in our diagram, so we want to sleep for 2, then we want to move 0 to P0, and sleep for 1, and then move 100 to P0, and sleep for 1, and I think this should work. Let's step. They're both sleeping. Step. Now we'll move 100. Step. You see, these processors, you're graded on several things: how expensive this is, how much power is used. The processors only use power when actually executing instructions, so sleeping doesn't use power. So far so good. Sleep 1. Alright, I think I can... Okay, advanced will go a whole time unit ahead, where step goes a instruction at a time. And I think we're good, so I'm just going to hit simulate here. And Chippy's tips. You just continue one test run, let simulation continue running for all 4 to complete the verification process. Alright, production cost. I believe these... Yeah, they're 3 yen. So we have 2 of them, 6, so we're basically everybody. And we use 60 power. Apparently it's possible to use less power. I'm not sure how to do that. There's probably a way. I mean, it definitely seems like it. Hey, we have a new mail. Thanks for your prompt work on the blinking lights. Looks okay. Should be blinking lights, but looks like some more flavor text. A bunch of new signups this week, so let me introduce myself. I'm your host, Tilly Liu, on this fun little mailing list for expatriates in Shenzhen. Here to demystify some aspects of your life and culture here. Well, you can pause and read that if you want. I'll get on to some more game, though. Factory floor has some examples of older equipment that require control signals to be amplified. We had a device to adjust the signals for this type of machine, but it was recently broken. Smash. I wonder if something's going on behind the scenes. There is usually a more sinister story going on behind the veneer of some of Zachtronics games. Although in Infinifactory, it was kind of right up front. You were abducted by aliens, but SpaceChem, as you got further into it, there was a darker story going on. I actually never completed SpaceChem. Got pretty far into it, but got stuck at one puzzle. Let's continue here, though. Smash, hang on a second, what happens? Everyone okay? No need to worry. Move along. Let's open the design. So we got control in, control out. Control in is simple input. Connected equipment, control out is simple output. Connected other equipment, signal from control in should be multiplied by 2 and copied to control out. Sounds easy. Move P0 to ACC. Add P0 to ACC. I'm gonna do add. It will accomplish. Actually, that should just be that. Add P0. Accumulator is implied. That in a normal computer, multiplying takes longer than addition, and addition will still cause it to be doubled. Now we're gonna move ACC to P1. Don't know if that actually applies here, but we will see. I think that's done. I think that's done. Production cost 3, power usage, what is... Oh, we want to show that. Let's go for simulate. And, hey, look at that. That appears to be doing what we want. $240 power. Someone got it under 240. None of people on my friends list, but someone got it over 240. Let's return to email. Looks good, thank you. Take care, yeah? Alright. Please enjoy a game. I am enjoying a game. My daughter isn't learning programming. She created a simple card game. Would anyone like to try and give some feedback? Put a link on everyone's desktop. She's interested in becoming a game developer. Wow, that is both a lot more polished and far harder than I was expecting. Let's look back. Hey, we Solitaire. Ooh, that's not Solitaire as I know it. Twins stack 3 suits from 1 to 9. 3 suits, 1 to 9. Cards can be stacked and moved to the center of the table only if they are alternating suits and decreasing values. Free cells at the top can store 1 card of any type. Where all 4 dragons of a single type are exposed, they can all be permanently moved to an open free cell by pushing the corresponding button. Okay, don't usually play Solitaire, but can I put that on there? Oh, yes I can. Alright, so it's just can't be the same. It doesn't have to go in a specific order. So really it sounds like we want to expose these dragon ones. I'm just gonna play this for a minute till I get stuck. 6 on there. Put this 2 on this 3 and this 2 on this 3. We need the 1. The 1's exposed. I guess this is the last card. We have any 5s? Well, we got that one, but we can put this one here. 5. Any 4s? This 2 can go here. I'm sure this is not the most interesting content, but if I put this here and this here, that goes up. Can I move this whole stack over? And if I move that here, 1, 2. Ooh, that was actually pretty good. I can't put this up here. No. We have 2 5s. So I am going to move this 5 there. And then 6. Problem is, I think I might have gotten stuck because I move this here, I move you here, 6 on the 7, move all of you. Can I put you on top? No. 6 sevens, 5. Okay. This is tough. 5, 6, 7, 8, 9, 4. Hey, this 4 is kind of holding us up, but I need to get a free space to put this. Where can I move you? I don't see any place. Yeah, I think that's about it. I think I'm stuck here. All right, let's go back. Not control panel. Let's new part. This is the MC6000, which I was describing earlier. It's in the manual. Updated agreement has given us access to a new part, the MC6000 microcontrollers, much like the 4000. Data sheet can be found with your other papers. Also, the bridge part reorder is in. The bridge enables jumping over traces and may be useful for smaller boards. This time we have many, so there's no danger of running out again anytime soon. So apparently there's a new bridge device that lets you cross wires without them attaching. Orbital selfie. Trips just starting at R89,999. Dear Venturer, experience the stars of Earth. The stars and the Earth as you've never seen them before. Enjoy surprise and delight for true weightlessness. And of course, take pictures of yourself that nobody will soon forget. Do you know that there's never been a better time to take a trip into low Earth orbit? Demand is skyrocketing, and prices are cheaper than ever. Now's the time to get in on this trend, which has been popularized by international superstar Cool Dad and many others. Tickets are going fast. JSC Space Adventures Moscow. Before playing this, I did read that is around or less than $2,000. So I'm not sure what year it's supposed to be. Pulse generator. In order to test some of our new manufacturing equipment, we need a pulse generator with certain requirements. However, instead of buying one on the marketplace, I thought we could just simply create our own. For this project, you'll need to make use of conditional execution. Please continue your study of the language reference. Let's open a design. Button is a simple input connected to a button. Pulse is a simple output connected to an electronic device. When the button is pushed, pulse generate pulses as indicated in the verification tab until the button is released. Okay. I think we can... Now here's bridges. I think we can use a simple one of these. Let's look at the tab here. So when the button is pressed, go high and then low, high, low, high, low. And so forth. Conditional execution is a little interesting here. You basically prepend statements with a with plus or minus, and it basically plus indicates it should be executed if the previous conditional was true, and minus indicates it should be executed if the previous conditional was false. And all other statements are always executed, so you can actually have a test, and then much later use the result of that test. So we're gonna test greater than 1. I think that is test that P0 is greater than 100. If so, we're gonna invert the accumulator, and then move the accumulator to P1. Actually, we want to test greater than 99. Actually, we want to test that it's equal to 100, not greater than. And that's EQ. Otherwise, we want to move 0 to the accumulator, because as soon as the button is released, like here, you're right, move. Here, we keep it low, and anytime we immediately want to start. I think that may be it. Let's step this one, because I'm not quite as sure about this. So skips the not. Oh. Let's reset. We want to sleep for a unit at that time. So we want to move 0 to the accumulator, and then output the accumulator, and then wait. Okay. This is now true, so we want to knot the accumulator. That sets it to 100. It's not a binary knot, but that is explained in the manual. It's basically a input-output knot. Look at that, we're alternating. I think we're good. I can hit advance here. It's this one right here that I'm not quite sure, but that should work. It does simulate. And I think that's a successful run. Okay, well, we've done it cheaply, and there is a bump here, but apparently there's a way to use, well, it looks like half the power, so that would mean half the instructions, so I'm not really sure how that would work out. Well, that will be later optimization. Looks okay, suitable for our purpose. Well, let's do one more. Light up signs, that can't be too difficult. Animated esports sign. It begins, we got this incredible deal with a major esports personality, the Solid Steel Gamer. His team's contracted with us to make light up signs that actually animate for her fans. As long as we keep the cost down, they're going to want tons of these to hand out at matches. Looks simple, just a few states. Okay, hopefully it is simple. Open the design. Chips tips, drag with the middle mouse button or the left mouse button while holding Alt K to look at different parts of your design. Click 0 and click 1 are simple outputs connected to display segments corresponding to a clicking animation. Drink 0, drink 1, and drink 2 are simple outputs connected to display segments corresponding to a drinking animation. Control the display segments. Fix repeating signals as indicated in the verification tab. Okay. Alright. This is the more expensive microcontroller. It only has 2 simple outputs. If it had 3, how do I get rid of you? Let's do part of this at a time. We're gonna go P0 and P1. I know I can do this part. Move ACC to P1. Not move ACC to P0, and then sleep 1. Alright, that's doing these. Ooh. Alright, we now need to do these drink. Okay, look, that's actually controlling the little finger animation. Now we can't do drink with just one P6. It doesn't have enough outputs of the right type. So I think I'm going to do it with how does this actually work? No. Oh, alright. Chip, can you get out of the way, Chip? Let's... If I move you like that... Okay. I'm just going to move this because I'm not sure how to move that tooltip, and this will work. Alright, you're going to do 0 and 2, and you're going to do 1. going to move 100 to P0. And then it's 1, 2, 3, 4, 5, 6. 6. 6. Then we're gonna move 0 to P0 and sleep for 2. And we're gonna move sleep 2. We're going to then move 100 to P1. Sleep 2. Sleep. This should be 1, and this should be 1. Okay. A little confused. 6. Then that goes low. We wait, and then this one goes high. Now that should be a sleep 2. Sleep 2. And we're going to move 100. Sorry. 0 to P1. 1, 2, 3, 4, 5, 6, 7, 8. Sleep 1. This only has 9 instructions, and I need 10, I think. To P0, and I need 1 more sleep. Let me try. One, 2, 3, 4, 5, 6, 7, 8, 9. Oh, wait, no. Sleep 1. And then this is going to put... That's it. There we go. That should be these 2 waves. This guy, I am going to... gonna use... I'm not gonna have the crazy timing. I'm not gonna have as crazy timing. This is a label. It works with a jump instruction. I'm going to test EQ 0. Or P0 and 0. If it is, I don't even need the label. If it is 0, I want to move 100 to P1. I want to sleep 1. I want to move 100 0 to P1, sleep 2. 1 plus in front of there. And then I want to move 100 to P1, and then sleep 1. Otherwise, I just want to sleep 1, which means I can take the plus off of this. So basically, this should see if P0 is 0. It's going to start off at 100. So it's going to sleep 1. It's going to test again, sleep 1. Eventually, this will go down to 0. At that point, we will output 100. We'll wait. We'll output 0. We'll wait twice. Output 100. And then wait once. Again. And we want to then put that back down. I think that should work. Reset. Instruction-wise, I need to wait for this to output before I do the test. Now we're doing the test. Sleep 1. Alright. Here's where it all goes. Okay. Looks good. I think we did it. Let's simulate. And, interested to see how I did. Using 344 power. But power usage is high. There's obviously a better way of doing this. Someone did it with 6. How do you do it with 6? We don't have the right output pins unless you can hook one of these X pins up. High on power. Looks like you can do it maybe 225, 200. I obviously have too many instructions somewhere. But I think that's gonna be it. Oh, I didn't mean continue editing. Which this one uses the most power. Wish I could move this out of the way and see the finishing power. That one only uses 30. Well, it's sleeping a lot of the time. You know what? We're gonna change this. We're gonna use less power. This one we can definitely rewrite. And hey, that's part of the game and part of real programming. We're gonna power starts off low, so we're gonna sleep. That's 6. Sleep 6. Move 100 to P1. Sleep 2. Move 0 to P1. It's not 2, it's 1. This is 2. 100 to P1. P1. And then 0 to P1. Simulate. There we go. That is 251. That's probably the intended way of doing this. Was higher. Can get a little lower. Not quite sure how. Same cost though. The result looks great. Love the way it looks. Like the solid steel gamer is really clicking the mouse button and drinking her soda. This is going to be huge. Alright, well, I'm going to call this a video. Thanks for watching. If you like this game, it's available in Steam Early Access. I probably should mention that while this is Early Access, you know, you can see it looks really complete. I played Infinifactory in the same state. It originally came out in Early Access, and it had about, well, it had the whole first campaign, and it was really polished. There was just some tweaks to the gameplay and some of the puzzles. Like, I believe they changed how rotators work slightly in one of the updates. But basically, updates, you know, just tweaked a few things, added more options, and added more puzzles and components as things went along. I'm sure this is going to be doing something similar. So it's very playable. You know, basically complete game that they're just going to be improving and tweaking. And it's not like, you know, half the game is missing and complete features are missing. This is, you know, basically a done game that they're just using Early Access to get some testers, more testers. I'm sure they do have testers, and, you know, user feedback and things like that. So, thanks for watching, and I'll see you guys next time. See you then.